Hello students, hope you are preparing well for the exam. Now let's proceed to understand the laying and testing of pipes. This is a crucial step in water supply systems to ensure that the pipes are properly installed, aligned, and free from leaks or obstructions. Laying and testing of pipes. The process of laying pipes involves several steps to ensure that the pipeline is correctly placed and securely joined. Let's break down the process into various steps. Steps involved in laying pipes. 1. Marking the center line and width of the trench. 2. Excavation of the trench. 3. Side protection of the trench. 4. Preparation of the subgrade. 5. Dumping of materials. 6. Laying and joining of pipes. 7. Testing of pipes. 8. Filling up the trench. Let's discuss each step in detail. 1. Marking the center line and width of the trench. The center line of the proposed pipeline is marked on the ground using pegs placed at 20-meter intervals. This is done using a theodolite for accuracy. The general excavation width, W1, should be about 30 centimeters more than the external diameter of the pipe. At joints, the width of excavation, W2, should be 30 centimeters more than W1. The depth of excavation at joints should be 15 centimeters more than the normal depth. The clear length, L, at joints should be double the length of the joint. 2. Excavation of trench. Excavation is carried out according to the markings on the ground. The excavated earth is dumped on both sides of the trench. The trench depth should be a minimum of 90 centimeters to protect the pipeline from external damage. Special care must be taken to avoid damaging underground cables or utilities such as telephone or electrical lines. 3. Side protection of trench. If the soil is hard and stable, side protection is not required. In loose or unstable soil, side protection is essential to prevent the collapse of trench walls. Side protection is done using sheet piles made of wooden planks or iron sheets, supported by timber struts, blocks, and wedges. 4. Preparation of subgrade. The subgrade is the prepared base on which pipes are laid. The preparation method varies based on pipe diameter. For small diameter pipes, the subgrade is prepared by ramming a layer of sand, clayey soil, or murum to a thickness of 15 to 30 centimeters. Sometimes, a single layer of brick flat soling is provided and rammed for additional strength. For large diameter pipes, the subgrade is prepared with a cement-concrete foundation 1:3:6 ratio over a layer of brick flat soling. Concrete benching is provided to hold the pipeline in position. Grooves are provided on concrete foundations or murum subgrade at joint locations for better alignment and stability. 5. Dumping of materials. Pipes and other materials for jointing are dumped on the excavated earth along one side of the trench. Care must be taken to avoid damage such as cracking or breaking during unloading. 6. Laying and joining of pipes. Once the trench bed is properly prepared, pipes are carefully dropped and placed side by side. Small diameter pipes can be laid manually. Large diameter pipes require mechanical devices like cranes for proper placement. Pipes are then joined using appropriate jointing methods depending on the type of pipe material, example, threaded joints for GI pipes, bell and spigot joints for cast iron pipes. 7. Testing of pipes. Before putting the pipeline into service, various tests are conducted to ensure strength, alignment, and watertightness. Common tests include water test, pressure test, straightness test, obstruction test, smoke test, leakage test, empirical formula. Let's discuss each one briefly. Water test, pressure test. Used to determine the water tightness of the pipeline. The lower end of the pipe is closed, and water is filled from the upper end. The pipeline is subjected to test pressure. If seepage exceeds permissible limits, the weak points are identified and rectified. 2. Straightness test. A light is placed at one end of the pipe and a mirror is placed at the other end. If the light is clearly visible, the pipe is straight and unobstructed. Any obstruction will be visible in the mirror. 3. Obstruction test. A ball slightly smaller than the pipe diameter is allowed to roll down. If the ball reaches the lower end, it indicates that there is no obstruction. Otherwise, the blockage is located and rectified. 4. Smoke test. Conducted in house pipelines laid above ground. Smoke under pressure is introduced into the pipe for 15 minutes. Leakage points are identified by observing where the smoke escapes. Leakage test by empirical formula. The allowable leakage is given by L equals N multiplied by D multiplied by the square root of P divided by 3.3, where L is equal to allowable leakage in cubic centimeters per hour, N is equal to number of joints, D is equal to diameter of the pipe in millimeters, P is equal to applied pressure in kilograms per square centimeter. If the actual leakage exceeds this calculated value, the leakage point must be identified and corrected. 8. Filling up the trench. After testing and necessary corrections, the excavated earth from both sides is placed back into the trench in layers of 15 centimeters. Each layer is lightly compacted using a tamping rod. The top surface is rammed with extra earth in the shape of a ridge, which gradually settles over time to form a level surface. Alright, so that covers the entire process of laying and testing of pipes. This ensures that the pipeline is correctly aligned, secured, and free from leaks or obstructions before being put into operation. That's all, students. We'll meet you in the next important video. Until then, keep preparing. Thank you.